Welcome back to the channel. In today's video, I'm going to continue my series on exponents and talk about division. So when you're dividing by exponents, you could have something like this, where you have x to the 7th divided by x to the 4th. That would be the same as this, simply written in fractional form. Now, remember from one of my previous videos that you could expand this whole thing so that the numerator is x times itself 7 times, and then the denominator is x times itself 4 times, because they're x to the 4th and x to the 7th respectively. Now, if we were to view this as a fraction, we could cancel out the terms because there's x values in both the numerator and the denominator. So we could take the x values in the denominator and they would cancel out with the ones in the numerator. So those two would cancel out, these two would cancel out, so would these, and then these. Now at this point, we don't have any x terms left in the denominator. So at the top, we're left with just 3 x's. So we have x times x times x. Now, obviously, that's equal to x cubed, or x raised to the 3rd power. However, it's important to note what we actually did here. We had 7 x terms in the numerator, and we had 4 in the denominator. For each term that we had in the denominator, we took 1 away from the numerator. So we had 4 x terms multiplied with each other in the denominator. We took those away from the numerator. So essentially, we took 7 of our x's in the numerator and took away 4. And that left us with 3. This should give us a hint as to what way we can use a shortcut to make this process faster. Instead of having to write this whole fraction out with the expanded terms, we can simply take the exponent of our numerator, which is 7, and subtract the exponent of the denominator. So, again, 7 minus 4 is 3, so we have x to the 3rd power. So this tells us that x to the 7th power divided by x to the 4th power is simply x to the 3rd power, or x cubed. And we've proven it using the long way as well down here. Now, there's something that you have to be careful about. If we had y to the 7th power divided by x to the 4th power, the same rule wouldn't apply, because that would be something like this, where we have y times itself 7 times in the numerator over the denominator, which is x times itself 4 times. Now, the x and y are not the same terms. Obviously, x and y are different variables, so they wouldn't cancel out. If that's hard for you to understand, let's write it out. The top part would simply be y times itself 7 times. So here we have y times itself 7 times, and then the numerator would be x times itself 4 times. So here we go. We have 4 x's on the bottom multiplied with each other. Now, x and y aren't the same. Before, we had the same variable in the numerator and the denominator, so we could cross them out like this. However, for this example, that won't work. You can't simply cross out the x and y's because they're different variables. So that means y to the 7th power divided by x to the 4th power is just simply y to the 7th power divided by x to the 4th power. Nothing special about it. However, the trick is still really good when you have the same types of variables in both the numerator and denominator. So let's go ahead and do a few examples like those. Okay, so let's say you're given a problem like this. Try pausing the video and solving it on your own. Okay, so by now I assume you have the answer. For this one, we can use the trick because we have the same variables in both the numerator and the denominator. A is up here and a is down here as well. So instead of writing everything out like this, and the same thing on the bottom, all we have to do is write a raised to the 22nd minus 8th power, because we're subtracting the exponents. What is 22 minus 8? Well, 22 minus 8 is 14. So we can rewrite that as 14. and that would mean that our final answer is a to the 14th power. Now that's pretty easy. Let's try something a little bit harder. Let's say you have z to the 15th power, and it's divided by z squared times z cubed. How would you go about doing this? Well, this question uses an additional concept, which is the multiplication of numbers with exponents. I've already made a video about this, so if you haven't seen that already, I've included a link in the description below. However, if you have seen that video, then you'll know that when you're multiplying numbers with exponents and they have similar bases, like z in this case, then you can simply add the exponents. So we can carry over the numerator, but now we know that our denominator is going to be z to the 2 plus 3 power. It's quite opposite to the division of numbers with exponents, and it's meant to be that way. It's quite simple. When you're multiplying, you're adding the exponents, and when you're dividing, you're subtracting the exponents. So on the bottom, we have z to the 2 plus 3 power. We know that 2 plus 3 is equal to 5. So we have z to the 5th power. Now we know how to do this. This is simply z to the 15th power over z to the 5th power. So we could rewrite that as this. And here, 15 minus 5 is equal to 10. So we could replace that with a 10. And there you go. That's the answer. So as you can see, this is a really handy trick for solving questions that involve both division and exponents. If you found this video helpful, please make sure to leave a like down below. Thanks for watching, and I'll see you guys very soon.